Saxon's Trig, lesson 85, is about advanced trigonometric equations. We've obviously been doing trigonometric equations, but this is going to be advanced, so obviously a little more complicated. And then clock problems. So part A, advanced trig equations. They again remind you of your basic three equations. So sine squared theta plus cosine squared theta equals 1. You should have that one definitely memorized. These are a little bit harder. Tangent squared theta plus 1 equals your secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. All right, so you should have them in your notes, but here they are again. And then they say, all right, we're definitely going to use these and probably manipulate them. Let's jump into example 1. Solve 3 tangent squared theta equals 7 secant theta minus 5. And the answers need to be between 0 and 360. Okay, this is not a prove from one thing to the other. It's an actual solve. I do immediately see that I have tangent squared and secant in the same problem, and that I can't work with because they're two different concepts. Can I change tangent squared to something else? I can't really change secant because it's its lowest form. I can make it 1 over cosine, but that's just making things messier. But yes, up here, my tangent squared can be substituted. So tangent squared solve for, that means minus 1 over here. So what I have is secant squared theta minus 1. So 3 times that substituted. Then I'm going to go ahead and move this, making it minus 7 secant theta, and move the 5, making it plus 5, so the whole problem can equal 0. And then I need to distribute before I can simplify. So 3 secant squared theta minus 3 minus 7 secant theta plus 5 equals 0. Keep my 3 secant squared theta minus 7 secant theta, and the negative 3 and positive 5 are like terms, so they're going to go together and make positive 2 equals 0. Okay, can I factor it, or do I need to quadratic it? So remember that 3 secant squared can be written as 3 secant with a plain secant, because 3 times 1 is 3, and secant is secant squared, and I will put my thetas in there. All right, so now whatever numbers I fill in here, this one is going to be multiplied with the 3 as I try to make my middle term. So just keep that in mind. This is why it's advanced, because this factoring is trickier. All right, so the only way to get 2 is 2 and 1. If I put the 2 here and the 1 here, that's going to be 3 and 2. 3 and 2 can't make 7. If, however, I put the 2 here and the 1 here, this makes 6. 6 and 1 can make a 7. Great. Remember that the sign in the middle should go with the larger number. And I don't mean the larger number between the 2 and the 1. I mean the larger number of the overall 6 and 1, so that just happens to be here with this. So this is going to be negative. So negative 6 and negative 1 makes negative 7. And we always double check negative times negative is positive for the last part. Okay, beautiful, it did factor. Equals 0, still there. Now we can solve for each of these secants. So secant theta will equal positive 1 divided by the 3. And here, secant theta will equal positive 2 when I move it over. All right, so my quadrants for secant. Secant is opposite of the word cosine, so I need to deal with the cosine quadrants. All, not students, take calculus, so yes. The secant then is the opposite of cosine, which was ca, adjacent over hypotenuse. So this will be hypotenuse over adjacent. Hypotenuse 1, adjacent 3. Uh-oh, I cannot have a side that is longer than my hypotenuse. It's not allowable. So this one gets thrown out. Now let's see what happens over here. it's positive, so same quadrants, same hypotenuse over adjacent implies over 1. Hypotenuse is 2, adjacent is 1. Oh, that's acceptable. So if I have that, then I recognize this as the root 3. Opposite root 3 is the 60 degrees. So for the first quadrant, that's 60 degrees. Here I'm shy of 360 by 60, so that's 300 degrees. And that's what theta equals. Now, example 2. 2 sine squared equals 3 cosine. Oh, again, I've left those symbols off. Just a second, I wrote something wrong. 2 sine squared equals 3 plus 3 cosine. Too many 3's, that's what threw me off. All right, and bounded between 0 and 360. Okay. I have a squared. However, this one is sine squared. This one is in the word cosine. Can't keep that. So I'm going to have to substitute for sine squared. So let's solve for sine squared up here. So we're going to have 2 multiplying with 1 minus the cosine squared, when I moved it, equals 3 plus 3 cosine. No changes over there. Distribute 2 minus 2 cosine squared. I'll go ahead and minus my 3 cosine, so I can set it equal to 0. I don't like the negative 2, but it is what it is at the moment. Negative 2 cosine squared minus 3 cosine. 2 minus 3 go together, make negative 1 equals 0. And I'm going to change everybody's sign so that I'm not dealing with the negative. So this is positive, positive, and positive, or the same as shifting everything to the other side. And because the 0, when you make it negative, it's still 0, doesn't really matter. Okay, so let's try factoring 2 cosine. 1 can only be 1 and 1, but again, this 2 is going to multiply with this 1, so I have 2 and 1. Oh, yeah, I can make a 3 out of that. So the larger number was 2. It has to be positive, matching the sign in the middle. How do I go from 2 to 3? I add another 1, and positive is positive. Good, no problems there. So now we solve. Cosine equals negative 1 divided by 2, and here cosine equals negative 1. All right, so now my cosine quadrants are negative. It will not be in all or calculus. So it will be in students and take. So cosine adjacent over hypotenuse. So the adjacent will be negative 1. Hypotenuse will be 2. Yep, recognize that with my root 3's. And that means 60. So this is 180 shy of the 60. So that's 120. And then 180 plus 60 more, 240 degrees. Theta equals. And now this one over here is the same quadrants because it's negative, implied over 1, adjacent and hypotenuse. So the adjacent is negative 1, hypotenuse is 1. Oh, well, that means if they match, the other sides have to be 0. So I'm not going up or down, I'm just going over. So that's 180 degrees. And just checking the answer there. Yep, that's all 3 of those. All right, example 3. They give us 2 tangent squared equals secant minus 1. Keep it between 0 and 360. So again, I've got tangent and secant words that will not work. So let's deal with our tangent squared. That's going to be secant squared minus 1. Then we substitute. So 2 secant squared minus 1 equals secant minus 1. Distribute 2 secant squared minus 2 minus secant plus 1, because I moved those over, equals 0. And put this in the right order. 2 secant squared minus secant minus 1, from putting negative 2 and 1 together, equals 0. And can we factor we're going to try 2 secant and secant. 1 is 1 and 1. All right, so this is 2 and 1. I can make a 1 out of that. It's negative, so the 2 has to be negative. How do I go from -2 to -1? I add 1, and we check positive times negative is negative. Oh, yep, factoring worked beautifully. So secant equals -1/2, and secant equals 1 by solving. All right, secant is the opposite of cosine again. So we know that this is hypotenuse over adjacent. It's negative, so it won't be in all or calculus. So again, we're in quadrants 2 and 3. Hypotenuse is 1. Adjacent is, oh dear, we have that problem again. I can't have a side longer than, so that gets thrown out. And then here, secant is positive, so all and calculus, 1 and 4. Implied over 1, hypotenuse and adjacent. So hypotenuse is 1, adjacent is 1. They match, so this is zeros. Not moving up or down, I'm just moving over, so that's definitely 0 degrees. Can I use the 360? No, because it said less than 360, so all I can keep is that theta, was theta, right? Yes, theta is 0 degrees. All right, now we move on to clock problems. They take the time to tell you that this is based on rate times time equals, and now they're changing it instead of jobs to spaces. And then they say, I have the rate of the big hand, I have a rate of the little hand, I have time of a big hand, time of the little hand, and then there is whatever the gap is between those hands that is the specific piece to the problem. So what I have discovered is that since these formulas always apply, the rate of the little times the time of the little is your seconds, and the rate of the big times the time of the big is your seconds plus whatever the gap is. And the rate of the big is always 1, and the rate of the little is always 1/12. And the time of the little and the time of the big, so however long it's taking those hands to move, they're identical. Okay, so because of this, rather than starting at the basic beginning with all of these equations and memorizing them, I have discovered that I can shortcut it. Always, this comes down to 11/12 TB equals whatever the gap is in this problem. And then when I solve, I'm immediately getting the time for the big hand. And so I just, because these are non-negotiable, they don't change, every single time I put them together, I get down to this equation. So let's just use the shortcut. So 11/12 TB equals, so in example 4, the hands of the clock point in the same direction. So you're picturing they're going in the same direction, I'm just doing it upward. And then it says, in how many minutes will they point in opposite directions? So I want the little one basically going down. And so I usually count it not clockwise, but counterclockwise to fill in my gap. But in either case, this is a 30-minute no matter which way I go. So this equals 30-minute gap. And then I just solve. So TB equals 30 over 1 times 12 over 11. Calculator that to however that's going to work. And it should come out to be 32 and 8/11 minutes. And so it actually takes, because the hands to actually, it's not going to be at the 30 because they're all moving. So the big hand is also moving just a smidge. That's where that extra 2 minutes comes from, to get them actually being opposite, because this hand is still moving at the same time this one is. So it makes sense that if it was a 30-minute gap you wanted, it's going to be slightly more than that. All right, so in example 5, it is 3 o'clock. So I know I'm going to start with my 11/12 TB equals, okay, so my hands at the moment are at 3. In how many minutes will the two hands of the clock point in the same direction? And so I want this one, the little hand, moving it counterclockwise. If I'm moving the big one, I do tend to go clockwise. I wanted to clarify what I meant there. So this one is moving to join. That's 15-minute gap. All right, so then my TB is 15 over 1 times 12 over 11. Calculator that work. And you should get a little over 15, so it's 16 and 4/11 minutes. If your calculator is giving you things in decimal, you may have to find how your calculator converts from decimal back to fraction, because with time, we don't want it in decimal format, we always want it in fraction format.